Now let's look at that same problem using the method that we just looked at. So here my n is equal to 2. So what I'm looking at is negative 1 squared, and then I have to take the second derivative of the Laplace of e to the 3t. So e to the 3t, I would end up with, oops, that's just going to give me a positive 1. So I need to take the second derivative of 1 over s minus 3, because that's the Laplace transform. So the first derivative would be negative 1 s minus 3 to the negative 2 power. And then the second derivative is going to give me 2 s minus 3 to the negative 3 power, which is just 2 over s minus 3 cubed. And that's the exact same answer I got when I did it with the shifts. Alright, our next example, I'll have the Laplace transform of t times the sine of 3t. So it's not in the form e to the at, so I can't use the other method. I have to use the derivatives. My n is equal to 1, so I get negative 1 to the first power times the derivative of the Laplace transform of sine of 3t. So this part, the Laplace transform, I'll just get negative dds of 3 over s squared plus 9. Now I'm going to take that derivative. So before I do that, I'm just going to do a little bit of a rewrite. So negative 3 s squared plus 9 to the negative 1 power. And that gives me a positive 3 times s squared plus 9 to the negative 2 power times 2s. So that will give me a 6s over s squared plus 9 squared. Alright, our next example is actually a combination. So I have the Laplace transform of t e to the negative 3t cosine of 3t. So here, this t tells me I can take the derivative, but then this part of it tells me that I have a shift. So I'm going to have to deal with both of them. So starting off, I have negative 1 to the first power, because n is equal to 1. And then I'm going to have to take the derivative of the Laplace of e to the negative 3t cosine 3t. So this is giving me my shift. And the shift is going to go from s to s plus 3. And this 3 in the argument is my k. So my k is equal to 3. So what I'm going to do is first take the derivative. Oops, sorry. Does not look like a 3. I'm going to first take the derivative, and then I'm going to go back and do my shift, because this is going to get really messy. So that negative is still out front. And I'm going to take the derivative of just s over s squared plus 9. Because that's the Laplace for cosine. So we have to use the quotient rule. So I have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So multiply that stuff out, we get negative s squared plus 9 minus 2s squared over s squared plus 9 squared which is just, I'm going to distribute that negative out front. So I ended up with getting these two combined to a negative s squared. So when you distribute it, you get a positive s squared minus 9 over s squared plus 9 squared. Alright, so I've taken the Laplace, but I haven't done the shift yet. So my last step is just wherever I see an x, I'm going to replace it with s plus 3. So I end up with s plus 3 squared minus 9 over s plus 3 squared plus 9, and that whole thing is squared on the bottom.